Tonight, we're going to take a journey through our solar system, but not in the way you might expect. We're not just going to talk about planets and moons. We're going to understand the true scale of our cosmic neighborhood. Because here's the thing most people don't realize. When you see diagrams of the solar system in textbooks or online, they're lying to you, not intentionally, but out of necessity. The real distances involved are so immense that if you drew everything to scale, you couldn't fit it on a page or a poster or even on a football field. And by the end of this journey, you're going to understand just how much nothing surrounds us. Before we start, if you enjoy these deep dives into space, a quick like or subscribe would really help this channel grow. Now, let's begin. Let's start with what you think you know. You've probably seen countless images of the solar system. 8 planets arranged in a neat line, maybe with the asteroid belt between Mars and Jupiter, all circling a central star that looks about the same size as Jupiter. These pictures are useful for showing what's in our solar system. But they're completely wrong about scale. If those pictures were accurate, if the planets were really that close together compared to their sizes, everything would be different. Worlds would be pulling on each other with their gravity. Collisions would be common. The night sky from Earth would be filled with giant disks of neighboring planets. But that's not what we see. When you look up at night, the planets look like bright stars. Even Venus, the brightest and our closest neighbor, appears as just a point of light. There's a reason for that. The distances between worlds are staggering compared to their sizes. Let's put this in perspective with a simple example. If you had a basketball to represent our star and placed it in the center of a room, where would you put Earth? Most people would guess somewhere in the same room, maybe a few meters away. The real answer? Earth would be a tiny ball about 2 millimeters across, roughly the size of a small bead, and you'd have to place it about 26 meters or 85 feet away. That's the length of about 2 school buses parked end to end. And that's just Earth, the third planet. Neptune, the most distant planet, would be about 900 meters, or almost 3,000 feet away. That's more than half a mile. You'd need a football stadium to properly show this scale, and most of it would be nothing but air. Before we can appreciate the scale of the solar system, we need to start with something familiar. Let's start with Earth. Our planet measures about 12,742 kilometers, or 7,918 miles across. That seems large. If you wanted to walk around the equator, walking 8 hours a day at a steady pace, it would take you more than a year. If you drove non-stop at highway speed, it would still take about 2 weeks. From our perspective on the surface, Earth feels enormous. There are oceans that stretch beyond the horizon, mountains that take days to climb, continents separated by thousands of kilometers of open water. You could spend your entire life traveling and still not see everything, but Earth is just one planet. And compared to some of the other objects in our solar system, it's actually quite small. The closest object to Earth, other than artificial satellites, is the Moon. It circles us at an average distance of about 384,400 kilometers or 238,855 miles. Let's make that distance more concrete. Light travels at about 300,000 kilometers or 186,000 miles per second. That means light from the Moon takes about 1.3 seconds to reach Earth. When you look at the Moon, you're seeing it as it was just over a second ago. Astronauts who traveled to the Moon during the Apollo missions between 1969 and 1972 took about 3 days to get there. The fastest spacecraft we've ever built, the New Horizons probe, would make the trip in about 8 hours. Now here's something interesting. If you wanted to line up planets between Earth and the Moon, you could fit all 7 other worlds in our solar system in that gap. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, if you place them side by side, would stretch about 390,000 kilometers or 242,000 miles. That's just slightly more than the distance to the moon. Think about that. The space between Earth and our moon is wide enough to contain every other planet lined up. That's how much nothing there is, even in this tiny corner of our cosmic neighborhood. Now let's talk about our star, because understanding its size is crucial to grasping the scale of everything else. Our central star is staggering in size. It measures about 1,392,000 kilometers, or 865,000 miles across. That's about 109 times wider than Earth. If Earth were a grape, our star would be a sphere about 2.4 meters or 8 feet across. But diameter doesn't tell the whole story. Volume gives you a better sense of the size difference. About 1.3 million Earths would fit inside. Imagine trying to fill it with Earths, like filling a jar with marbles. You'd need 1,300,000 of them, and there would still be space left over. Our star also contains 99.86% of all the mass in the solar system. Everything else, all 8 planets, all the moons, all the asteroids, all the comets, all the dust, everything together makes up less than 0.2%. This central body dominates not just in size but in mass. Every second, it converts about 4 million tons of matter into energy through nuclear fusion. This energy radiates outward in all directions. The tiny fraction that hits Earth is enough to drive our weather, power photosynthesis in plants, and warm the surface to temperatures that allow liquid water to exist. The scale is so large that if you were standing on its surface and looking at the horizon, that horizon would be about 30 times farther away than Earth's horizon is from sea level. The surface area is about 12,000 times greater than Earth's. You could wrap our entire planet's surface around it 12,000 times and still not cover it completely. Now that we understand our star's size, let's look at the planets, starting with the inner solar system. This region contains 4 rocky worlds: Mercury, Venus, Earth, and Mars. These are called terrestrial planets because they have solid surfaces you could theoretically stand on. Mercury circles closest to our central star at an average distance of about 58 million kilometers or 36 million miles. We measure distances in the solar system using a unit called an astronomical unit, or AU. 1 AU is the average distance from Earth outward, about 150 million kilometers or 93 million miles. So Mercury travels at about 0.39 AU. The smallest planet in our solar system, Mercury measures about 4,879 kilometers or 3,032 miles across. That's about 38% the size of Earth. If Earth is a grape, Mercury is a large peppercorn. What's interesting about Mercury is how slowly it rotates. One day on Mercury, the time it takes to spin once on its axis lasts about 58 Earth days, but it completes an orbit quickly, in about 88 Earth days. This creates a strange situation. Because it rotates slowly while traveling around our star relatively fast, one solar day on Mercury, from sunrise to sunrise, actually lasts about 176 Earth days. That's 2 Mercury years for every single day-night cycle. Mercury's surface temperature swings are extreme. During the day, temperatures can reach 430 degrees Celsius or 806 degrees Fahrenheit. At night, they drop to minus 180 degrees Celsius or minus 292 degrees Fahrenheit. That's a temperature swing of about 610 degrees Celsius or 1098 degrees Fahrenheit more than any other planet. Venus travels next, at about 0.72 AU or 108 million kilometers, which equals 67 million miles. Venus is almost identical in size to Earth, measuring about 12,104 kilometers or 7,521 miles across. That's about 95% of Earth's width. Venus is often called Earth's twin because of the similar size, but the similarities end there. Venus has a thick atmosphere made of carbon dioxide that creates a runaway greenhouse effect. The surface temperature reaches about 470 degrees Celsius or 878 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure at the surface is about 92 times greater than Earth's. If you stood on Venus, you'd be crushed and cooked simultaneously. Venus also rotates backwards compared to most planets. While Earth rotates from west to east, Venus rotates from east to west, so sunrise happens in the west on Venus. Even stranger, Venus rotates very slowly. One day on Venus lasts about 243 Earth days. But Venus completes one orbit in about 225 Earth days. This means a day on Venus is actually longer than a year on Venus. Earth, as we've discussed, travels at 1 AU. We'll come back to our planet later when we talk about what makes it special. Mars, the fourth world, circles at about 1.52 AU or 228 million kilometers, equal to 142 million miles. Mars measures about 6,792 kilometers or 4,220 miles across, roughly half the size of Earth. Mars is sometimes called the red planet because iron oxide, basically rust, covers much of its surface. The average temperature sits at about minus 63 degrees Celsius or minus 81 degrees Fahrenheit, much colder than Earth. One of the most impressive features on Mars is Olympus Mons, the largest volcano in the solar system. It stands about 21 kilometers or 13 miles high, roughly 2.5 times the height of Mount Everest. The base of Olympus Mons spans about 600 kilometers or 370 miles across. If you stood at the base, you couldn't see the summit because it would be beyond the horizon. Mars also has the largest canyon system we know. Valles Marineris stretches about 4,000 kilometers or 2,500 miles long. If it were on Earth, it would span the entire United States from coast to coast. In places, this canyon is about 200 kilometers or 125 miles wide and up to 7 kilometers or 4.3 miles deep. Between Mars and Jupiter lies the asteroid belt, a region filled with rocky objects. Despite what science fiction movies might show, this belt is mostly nothing. If you flew a spacecraft through it, you probably wouldn't even see an asteroid with your own eyes. They're spread out over such an area that encounters are rare. The asteroid belt extends from about 2.2 AU to about 3.2 AU. That's a region about 150 million kilometers or 93 million miles wide. Within this space, there are millions of asteroids, but most are quite small. The largest object here is Ceres, now classified as a dwarf planet. Ceres measures about 940 kilometers or 584 miles across. Despite being the largest object in the belt, Ceres is much smaller than any of the 8 major planets. If you could somehow gather all the asteroids in the belt and combine them into one object, the total mass would be only about 4% of the Moon's mass. The entire asteroid belt contains less material than our Moon. This tells you something important. The asteroid belt isn't the remains of a destroyed planet. It's actually material that never formed into a planet in the first place, probably because Jupiter's gravity disrupted the formation process billions of years ago. Now we come to Jupiter, And this is where the scale really starts to change. Jupiter circles at about 5.2 AU, which is roughly 778 million kilometers or 484 million miles. That's more than 5 times farther out than Earth. Jupiter is staggering. It measures about 139,820 kilometers, or 86,881 miles across. That's about 11 times wider than Earth. If Earth were a marble, Jupiter would be a basketball. But the real difference is in volume. Jupiter's interior is so vast that more than 1,300 Earths would fit inside with room to spare. Jupiter's mass is about 318 times that of Earth. Jupiter is so heavy that it contains more than twice the mass of all the other planets combined. Jupiter doesn't have a solid surface like Earth. It's a gas giant, composed mostly of hydrogen and helium. If you tried to land on Jupiter, you'd just keep sinking deeper and deeper into increasingly dense gas until the pressure would crush any spacecraft. Deep inside, there might be a rocky core, but we're not entirely sure. The Great Red Spot on Jupiter is a storm that's been raging for at least 400 years. Early astronomers spotted it through telescopes in the 1600s, and it's still there today. This storm is bigger than Earth. Our entire planet would fit inside the Great Red Spot with room around the edges. Wind speeds at the storm's edge reach about 432 kilometers per hour or 268 miles per hour. Jupiter rotates incredibly fast for such a large planet. One day on Jupiter lasts only 9 hours and 56 minutes. This rapid rotation causes Jupiter to bulge at the equator. The planet is noticeably flatter at the poles than it is wide at the equator. Jupiter has at least 79 known moons, and scientists keep discovering more. The 4 largest moons, discovered by Galileo Galilei in 1610, are Io, Europa, Ganymede, and Callisto. Io is the most volcanically active body in the solar system. It has hundreds of active volcanoes constantly reshaping its surface. The volcanic activity is driven by tidal heating. Jupiter's gravity squeezes and stretches Io as it travels, generating heat through friction. Europa is one of the most exciting places in the solar system for the search for life. It has a smooth, icy surface, but scientists are confident there's a global ocean of liquid water beneath that ice. This subsurface ocean might contain twice as much water as all of Earth's oceans combined, kept liquid by tidal heating from Jupiter. Europa is smaller than our moon, but it might harbor more liquid water than our entire planet. Later, missions found that Saturn's moon Enceladus also has a subsurface ocean with geysers shooting water into space, and scientists suspect several other moons, including Ganymede and Callisto, might have buried oceans as well. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It measures about 5,268 kilometers or 3,273 miles across. Ganymede is the only moon known to have its own magnetic field. Callisto is heavily cratered, preserving a record of impacts from billions of years ago.